Section 5.7 is just a summary of factoring techniques or a review of our factoring. So the first thing we always want to do is factor out our GCF, see if there's anything in common that we can factor out. This will help make your life easier by having smaller numbers to work with, as well as get you a complete factoring for your answer. Second thing, you want to see if there's any of these special cases. We could have a difference of squares, in which case our pattern would be that. You could have a sum of cubes following this pattern, or a difference of cubes, which would follow this pattern. If none of these three things work, we can always check if it's a trinomial. To factor it, we have to multiply to find two numbers that multiply to a certain number and then add to a different number. If we have four terms, we can try factoring by grouping. We also want to make sure that no group at our end has a common factor. If so, we want to factor it out. So this is just a double check at the end to make sure you got all your GCFs. And then at the end, if you want to check it, you can multiply it back together and make sure it works. So for this first one, notice we have a GCF of 2, which means we can factor it out. And we're left with x squared plus 3x minus 5. And now we want to find two numbers that multiply to negative 5 and add to 3. Well, those are our only options. Neither one works. So this is our answer. Notice it's not prime because we actually could factor something out, and so this is our answer. On this one, notice we can still factor out a 3xy. We're left with x plus 2y minus 4. Now notice the x nor the y have a squared. There's nothing else we can do with it. This is our answer. On this one, notice there's no GCF that we can factor out, but this is 10z quantity squared minus the quantity of 9t squared, so it is a difference of squares. So we can factor it into 10z plus 9t and 10z minus 9t. There's four terms, so let's try by grouping. Notice these first two don't have a common factor, so we don't want to try grouping them together. So let's try these middle two both have a b squared, so we can factor out a b squared. And then these two have an a squared in common, so let's factor that out. And now notice they both have an x squared plus y squared, so we can factor that out from both, and we're left with b squared plus a squared. Notice they are addition, not subtraction, so it's not a difference of squares, so we can't factor it anymore. On this one, notice we've got an a minus b quantity in here. We can use substitution, and let's just call this something else like m. So we've got 2m squared plus 5m plus 3. Well, now we've got to find two numbers that multiply to 6 and add to 5. 2 and 3 work. But now notice we didn't have an m in our original expression, so we have to substitute this m back out and use our a minus b. And notice it was 2 times this whole m, so it's 2 times this whole thing here. We can distribute. And we are done. On this one, notice we have a common factor of 2. Also notice, since it's addition, and these are to the 6th power, we can rewrite this as x squared cubed and y squared cubed. Now notice it is a sum of cubes. So we'll still have our 2 up front, but we can use our sum of cubes formula. And our x squared squared will give us x to the 4th. And then we'll have it plus x squared plus y to the 4th. And now we want to double check to see if this last part can be factored. So we need to find 2 numbers that multiply to 1, but also add to 1. And that doesn't work, so we are done here. This one, notice there are 4 terms, so we can try factoring by grouping. Grouping these 2, we can take out an x squared. Grouping these 2, we can take out a negative 4. Now notice this first part is a difference of cubes, so we can factor that as well. And the second one is a difference of squares. And now we're good. So one thing to keep in mind, just because you factor once, like notice we've factored here, you always want to double check to see if you can go any farther and factor any of those to get it in completely factored form.